Test 1, 2. Gotta turn my mic on.
Test.
Mic live out.
Okay, guys. I think we're on here. Let's if somebody will verify it. We've been real busy this morning.
I see Paul said, "What a motley crew," so it looks like we're there.
Turn it on.
Can you change the bottom third?
Slight technical difficulty.
Well,
Okay.
Yeah.
All right, guys. Hey, welcome to our D-Star broadcast. We thank everybody for attending, and we've got some people on the West Coast that are just now getting up, hadn't had their coffee yet, so hopefully we'll have a few more from the West Coast on here. We got a great group today. I'm going to try to introduce these guys briefly, and then I'm going to get out of the way. So you're not going to see me on the broadcast here too much. So let's talk about first our guest today. We've got Ray Novak, N9JA. Okay. And let's see. Ray got his start at MFJ back in, 1999, I think. And he moved up in his position there and then moved on over to ICOM and is now... Ray, what are you with ICOM now?
I'm the division manager for amateur and receiver products.
All right, there you go. So we got ICOM here to talk to us about D-Star today and their products and so forth, and then we got these other guys here. But Ray, let's see. Let me tell them a little more about you. Ray is real involved with ham radio. He likes to contest. He's been in a lot of big winning contests. He's active with the Boy Scouts and their merit badge, and I know ICOM is providing equipment to Boy Scouts of America. You can see Ray on Ham Nation every maybe not every Wednesday night, but he's definitely in the chat room there.
Bug him in the chat room.
Yeah, bug Ray in the chat room. And let's see, hey, Ray's wife, Cindy, just got her license. She went from nothing to extra in just a few months. She has a call of N9JA. So she's going to keep Ray on his toes there, I guess. Let's see, what do we got next? We got John Davis, B4QDX. And John was licensed back in 1969. He's from Nashville area. He's had a 35-year professional career in broadcast engineering, satellite communications, and wireless communications. And he presently lives in the Atlanta area. He is the emergency coordinator for Gwinnett, is that right? Gwinnett County areas, and a district emergency coordinator for the Georgia section. He's very active in D-Star, and he recently helped secure a grant from Georgia Emergency Management Agency, and they're putting in a statewide D-Star repeater network. He's also the co-founder of DStarInfo.com. He's a frequent presenter to D-Star people and meetings. He travels a lot. Does seminars across the country. Maybe a little later he can tell us some of the places he's been there. He also serves as the Georgia Vice Director for the Southeastern Repeater Association, and he holds an extra class license. And then we've got Robin Cutshaw here, AA4RC. Robin is an enterprise.
It's a picture too.
Yeah, he's he never sent us a picture. I had to go out on the internet and find it. Robin is a enterprise IT consultant by day, and what few hours are left, he spends all of his time on D-Star. In the early days of D-Star, he analyzed the network protocol, gateways, and controllers, and he created D+, a program that augmented the functionality to include things like EchoTest, CAN announcements, and linking. He then created reflector technology to connect multiple D-Star gateways to large conference bridges. And along with Mo Wheatley, AE4JA, he created the DV dongle and the DV access point dongle to allow the D-Star network connections to Macs and PCs. and he's constantly working on new features here. And then we've got Ed Woodrick, WA4YIH. Ed's been licensed since high school. I don't know how long it's been.
3 years.
3 years, so he's young here. He's been involved with a number of organizations throughout the years, including the Civil Air Patrol and areas, through his interest in emergency services, as well as a need to be a part of the state of the art. He got involved in D-Star. Ed is a D-Star evangelist.
Say hallelujah.
Hallelujah, right?
Hallelujah.
He started the www.dstarinfo.com website to help demystify D-Star. In addition, he created a D-Star calculator to simplify D-Star programming, as well as the D-Star downloads to directly program radios. In starting with the ICOM ID31A handheld radio, ICOM decided to use the information from the D-Star info database, and they preloaded it in the radios, so they know all the repeaters in your local areas worldwide, making it the first radio capable of automatically configuring the closest repeater. It's also an integral part in the Georgia D-Star team, responsible for many of their repeaters in Georgia. He owns his own repeater, which has traveled thousands of miles to demonstrate D-Star.
Back in the corner. Right?
Is this it right here?
That's it right there.
I'll point to it over here. I don't know if you can see it or not. Okay, and then, let's see. We've got a couple local D-Star guests here in Memphis. We got Rick, KA2BSM, and Michael, KK4IOH. Did I get that right?
That's right.
All right, and did you cut to their picture?
I did.
Okay. Oh, you did. There it is. Okay, very good. Okay, so we're going to get the show started here. I'll come back about every couple hours and wave at you guys, but that's about all I'm going to do. So I'm going to turn it back over to Ray Novak.
Good morning, everybody. What I'm going to start with goes over a little bit of the historical information about D-Star, where it started, the reasons for the modulation of codec, and the other items that have come into question over the years as people have started seeing the different propaganda out there for or against D-Star. So, Robin, can you go ahead and bring up our PowerPoint? So in the beginning, we started looking at all the various services that we have available to us. Broadcast, you look at your AM, FM, weather, TV, shortwave. Public safety, police, fire, land mobile, taxi, bus services, all the different type of corporations that would use radios for communications, aviation for general aviation as well as military. The one common thing that we all ran into was congestion. Looking at the different receiving devices, back then you would look at just a simple scanner or a wideband receiver, or a lot of us used our amateur radios to be able to receive those signals. But as we started seeing those services move towards digital communications, we started seeing changes in how we could receive those. There are now specialized scanners. There's digital radios for the broadcast services. And then as we're coming to you today, we're streaming over the internet. So these look like some challenges that needed to change. And in this evolution, the broadcast, they wanted to become more specialized service. They wanted to have a better quality of the service, interactivity, similar to what we're doing here, where they could receive customer feedback. They could also give you information over the stream. But the key thing was they wanted to stay competitive with today's changing technology in what they saw as a threat with being the cell phone technology. Public safety. There again, they wanted to go for increased capacity, functionality that they were seeing in some of the new commercial two-way radio devices. So they looked at how do they remain competitive and actually send more information by using less spectrum. Lamb Mobile, pretty much the same story again. And then amateur radio, what was seen by the JARL was a way of becoming more spectral efficient by increasing the capacity, increasing functionality on what you could do with the same radio without having additional peripheral equipment. Looking at remaining competitive with the perceived threats of the internet, cell phone technology, and things like that. But more importantly, how can we do this and keep experimentation fun for those that were coming from the software side of the world? So when we take a look at what DV or digital voice technologies that are out there, for amateur radio, one of the first ones was AOR with their HF Digital. There's recently been an announcement on free DV for HF. Elenco was the first one to release VHF and UHF portables, but no infrastructure to support it. Recently, we all seen Yaesu come out with a device, but it's still kind of undefined as far as the direction that they're going to go with it as far as the infrastructure. In Japan, Kenwood released a D-Star product as well as part of the team that announced D-Star back in 2001. And then ICOM has been extremely supportive of D-Star with building the first hardware pieces for it. Public safety, we've seen APCO 25, Phase 1, and now the announcement of Phase 2. We've seen municipalities use open sky technology. Commercial, you see Moto Turbo, you also see NXDN from both ICOM and Kenwood under the marketing names of NextEdge and IDAS. And then we're seeing from Europe the Tetra equipment. So as we go into some of the presentations we've seen in the chat room already, there's quite a few people that are new to D-Star. So I'm going to go over a brief summary of some of the terminology that you'll see. Terminology bandwidth. While we're accustomed to it being for frequency used, we now incorporate bandwidth for the data speed or the data being used. Narrowbanding. This is a migration to become more efficient in spectrum usage. Modulation. It is the use of RF. And it's real easy to get modulation and mixing the digital signal or the codec in one term, but they're two distinctly different parts of a signal. The vocoder, it's actually the device used for digitizing the audio. Data stream, it's a series of ones and zeros that are be over the internet as well as over the RF signal. BPS, that's your bits per second. That's how the data speed is measured. We also have the CAI, which is a common air interface. FEC, forward error correction. Synchronization, an identification key for alignment of the packets. Packets, different than what we're used to in packet radio. It's groups of digital code for distinct purposes. DV, digital voice. DD, which we'll be showing later today, which is the digital data. We also refer to it as 128K data. Digital cliff. This is what everybody's fearful of right now, but has nothing to do with the U.S. economics of a cliff. But this is the edge of coverage that you'll see. Some technologies not only have a digital cliff, but they have what's called a timing cliff, and that is the edge of the timing sequence to use the digital technology. Picket fencing. Usually you see it in a mobile, and it is an effect from multipath signals arriving at the receiver. Flutter. This is packet loss that occurs over the internet between the D-Star repeaters. R2D2, this is one that's real fun and we get to hear quite a bit, and is also referred to as R2D2 when they talk about flutter. But R2D2 is the sound that is made when the synchronization is lost and the vocoder does not know where to pick up and align the ones and zeros to get audio. Multipath, multiple versions of the same signal arriving at a receiver from slight time variations. BER, or bit error rate, measurement of acceptable signal. In FM, we talk about sensitivity, but for the data side of it, we look at what is the maximum bit error rate or minimum bit error rate where a signal is received in good quality. IP address, internet identification. In D-Star, the IP address is also aligned with the call sign, which is your amateur radio station or user identification. So we're headed into the historical review. D-Star was developed in the late 90s. It started as a Japanese government experiment for mobile data solutions. The goal was to get ISDN data rates, and with what we were able to do during the experimentation, there was also voice communications. The implementation was successful, and after the tests were done, the technology from the consortium of various Japanese manufacturers was then placed into development. But one side note out of the development was there was an application where it could be used for amateur radio. The JARL saw that amateur radio was becoming stagnant because of all the threats from the cellular telephone industry as well as the internet. So what could be done to take the technology and move it forward? Of the D-Star protocol, the Common Air Interface is a standard open source that anybody can build to. Now, there is an ongoing debate on whether or not, because of the codec being used, on whether it's proprietary or not, but I think Robin will be touching a little bit on this subject later on today. So a factoid, when questions start arising on why did the direction of development go in one way, or why was it done a certain way, why didn't the development go in a specific direction that we see over here in the U.S., the D-Star development was in Japan. They had to follow Japanese rules and regulations, which are vastly different than what we see here in the U.S., as well as in Europe and in Australia. Individuals in Japan do not own repeaters. The repeaters are owned by the JARL, and this was a very interesting thing that we discovered back in 2003. Only the JARL and some of the amateur radio clubs in Japan own the D-Star or own repeaters. Static IP addresses. This was something that slowed down the development of D-Star at the very beginning, and that was when static IP addresses were required. Over in Japan, the static IP addresses were normally handed out to users. In the U.S. and mostly everywhere outside of Japan, DHCP is the way that we've gone. In Japan, amateur radio is viewed as a hobby. In the U.S. and some other countries, it's more of a lifestyle. So there are a lot of things that we do and how we use it that the ICOM engineers look at and go, well, why do you do it that way? And it becomes a fun learning experience. The final piece of the puzzle is limitations. Some of the limitations are due to the competitiveness between the NTT in Japan and the telephone features such as roaming and international calling. So this is one of the reasons why the Japanese operators require a repeater call sign routing instead of being linked to a reflector or direct call sign routing. So introduced at the 2001 Tokyo Ham Fair, the original specs, and this is kind of interesting because it has evolved from that point to where we are today. The original specs were at 1.2 gig, the wave type for FM analog voice, as well as 0.5 GMSK digital voice and data. The communication speed was 8 kilobits for voice for the DV and 128K data for the DD mode. It was an open source vocoder at that point, and the data interface was using the 10BASE-T. You can look at the original files and the ARRL's technology area, and this link will be available, and the slides will be as well later on. Back in 2003, there was a series of articles released in QEX. If you want to be able to download and read these articles, if you don't have an old issue of QEX laying around, you can download them from the ICOM America website under the D-Star page. The series was released in July, August, September, October, November, and December. Part 1 was talking about the new mode introduction and the testing and historical recording of the tests, as well as why some of the design concepts. Part 2 was further outlining the design considerations for modulation as well as the codec, and Part 3 talked about the implementation. While these articles were in 2003, it was based on the information at that time, and we have evolved to where the D-Star stream is actually much narrower than what was originally outlined. So now I'm going to cover the codec and modulation. When you take a look at analog and digital, there's two distinctly different ways of looking at this. In an analog, you basically go straight from audio frequency to RF, where in a digital world, the audio frequency must be digitized into a data stream. The modulation for analog is FM, where the data stream is then moved to an RF representation through a GMSK modem. Along with the digital voice on D-Star, there's 2400 bit per second for the voice, 1200 bit per second for the forward air correction, and then 1200 bit per second for data. So the codec comparisons that they were looking at that time, there were several of them that came from the telephone industry or the cell phone industry, looking at GSM and IDEN. IMBE at that point was embraced by P25 devices as well as Inmarsat, but AMBE was something new, and it was depicted because of the MOS or the audio quality measurements that AMBE would be a more robust way of going and keeping the bit stream to a lower baud rate. AMBE now, other than just D-Star, has been embraced for P25 Phase 2, as well as used in DV dongles. When we take a look at the two comparisons, the very first one is Inmarsat. You've got the AMBE and a much wider 8 kilobit per second data streams. And you can see the 3.6 tests are very close to the audio quality that they were getting, which a much higher data stream. Then APCO did testing on the IMBE and found out that the IMBE was a more robust, better sounding audio as compared to the other technologies that were available. This information you can actually find on the DVSI website under the iambe.htm for further information. Looking at the digital voice systems tests, we can take a look at the different codec selections. There are three AMBE selections here, a 3.6 kilobits per second, 2.4, and then 2.0. And in the development, they wanted the best sounding audio possible while keeping the data stream and the amount of spectrum used as narrow as possible. So as you can see in the rating here, there's not much difference between 3.6 and a 2.4. Now moving on to the modulation, or I'm sorry, I should say the selection was to go with the 2.4 because of the audio quality, and then being able to put in forward error correction, which would improve the distances that you would be seeing using the AMBE vocoder. Modulation became the next question, and the key point on that is looking at the typical amateur and the amount of money that they would be able to spend on equipment. As you look at the modulation schemes, you have a trade-off: simplicity versus bandwidth. A simplistic design decreases the spectral efficiency, but the goal in it was to make it as spectrally efficient as possible. So when you look at that, you have to increase the complexity of the design. There's three key factors in this development, and that was available bandwidth, permissible power, and then inherent noise levels. As we see higher bits per second per hertz in the more complicated modulation schemes, you're looking at an expense increase in the type of amplification that you use, as well as the amount of power that is consumed. So the goal was to go with an MSK type where you would get 1 bit per second per hertz. Doing so allowed us to go to a complete 4800 bit per second data stream, which translated into a 6.25 kilohertz spectral. How that translates out is that would be the narrowest possible RF envelope to get a good audio stream to go across. So, getting the ideal modulation, these key items came into play, but there again the key goal was going with the 6.25. Along with this, looking at GMSK, we were able to get a constant envelope carrier. So what this came to is no amplitude variations, which translates into using existing ham, VHF, and UHF amplifiers. More efficient amplifiers then turn into better power consumption. So we're able to create a portable device that had decent battery life as well as decent coverage and getting good audio quality in one small package. You can read more about this in the section 2 of the QEX articles. So moving forward, why use digital voice? Key thing, spectral efficiency. To get a 2-meter pair right now, somebody has to die or give up their frequency, and that is not something that we see happen a whole lot. What we're able to do is put 2 D-Star repeaters in the same band space or same spectrum that you see 2 FM repeaters. So that'll keeps amateur radio going in the same direction that we see the commercial two-way, where they're refarming and becoming more efficient. It also shares spectrum with data, and this is a key thing because we'll talk about it a little bit later in one of the roundtable areas. You're able to get not only voice information, but information like GPS positioning, which Pete Lovell has worked to create a bridge between DPRS and APRS. And then it makes your QSOs routable. What I mean by routable is when it was first released and before Robin released D+, I could talk to one of my friends on any of the D-Star repeaters that were connected to US route by just programming in their call sign, and it would follow wherever that person was. So Robin has taken that and expanded it to where we now have reflectors and a lot larger communities out there. So what did the call sign capability do? You can call anybody, anywhere, at any time. And some of the new ICOM radios include an answering system that you can pre-program a message in if somebody calls directly to you, and it will respond, "I'm away from the radio, I'll be back in 15 minutes. And also it will log in the radio those that have called you, and you know who to try to call back. So how is this all done? Well, as we talked about, the call signs are key. There are 4 call signs in every D-Star transmission. There's the My Call, which is the originating station, RPT1, which is the originating repeater, RPT2, which is the destination repeater, and Your Call, which is the destination call sign. Now, there have been changes to that where the Your Call now can also be used for different commands depending on what software is running along with your gateway. But this is an example of the data header that is transmitted with every D-Star signal. This is what it looks like if you're looking at just the ones and zeros. The red section is the data header. Up in the very top where you see the black part of code right here, that is the synchronization key. The green are the voice packets, and then interwoven in here in the blue are the data packets. Whether the data is loaded with information or it's empty, it is always transmitted, and it is identified on who originated the signal in the red section. So that covers my section of it. It looks like I've got a little time for some question and answers here, so fire away in the chat room.
Taking a couple minutes, seconds. Release date for the ID51?
We're waiting on FCC certification for the 51, so it will be hopefully... Oh, I'm sorry, repeat the question. When is the release date for the ID51? Right now we're waiting on FCC certification for that, and hopefully it'll be shipping next month. Thank you, Fran. I'll remember that one. He says, "Why am I so ugly?" Thank you. Can one send text and voice at the same time? Yes, you can. When you transmit, there's several ways of doing it. One is behind the call sign. There is a 4-character ID section that a lot of us put in what radio we're using. And then in another section, you can program in a text message. And the text message could be something very simple for when you're doing a net, whether you have traffic or no traffic or emergency traffic. You also have GPS information that is transmitted every time you key up, if you have that function turned on. Another question. If I'm using a repeater, am I tying up the whole repeater or just... Oh, you guys are fast. Hold on a minute. If I'm using a repeater, am I tying up the whole repeater just for me? With D-Star, that's a little bit of a trick, because with a stack, and can we show the repeater over here? Okay. On this particular repeater back here, we have a repeater controller and we have 2 RF modules. You're only tying up one RF module that you're going into. And unlike the linked analog repeaters, you're if you're connected to the internet to another repeater, you're only tying up 2 RF resources for your communication. Where you expand on that is if you're going through a reflector, which we'll cover a little bit later. But it really depends on what you're doing. You are rebroadcasting locally through your RF module here, but also on the other end as well. I see Computer Doctor here is sharing one of the myths that are out there on D-Star being doomed if it continues to be a closed source for the codec. DVSI has done a lot of work. There's probably a DVSI chip in every digital device out there, as they are an industry leader. The chips are not very expensive, so if you want to do your own experimenting, they are available in small quantities, large quantities, whatever kind of quantity that you want. And when you take a look at some of the other commercial two-way stuff, they're using codecs by DVSI as well. So I do not see that occurring, as a lot of people have said. Any plans for D-Star Phase 2? Have not seen anything as far as Phase 2, and that's really a difficult question to answer. We are now on, with the ID51 and the ID31, we are on probably our 5th generation of user interfaces. Robin's software has expanded the functionality of the repeaters beyond what G1 and G2 softwares released by ICOM have been. So as far as the modulation and the codecs, I don't see those changing. So the functionality on the software side of it and the user interfaces are the two things that I will see continue to grow.
The question is, if you're streaming over 1.2 gig link, will you be tying up the repeater port for users?
I'm sorry, what was that?
Let me have my position. If you're streaming over 1.2, will you tie up the repeater?
Now the question was, if you're streaming over 1.2, do you tie up the repeater? The one nice thing about the repeater controller on the ICOM stack is you can have 4 independent RF repeaters going off of one repeater controller. And anytime that you'll see any lag or anything like that is if you're really hammering your bandwidth on your internet provider.
Does a D-Star repeater have a time limiter for the transmitter?
There is a timeout timer on the D-Star repeater itself. It falls within the FCC guidelines of 10 minutes.
With the FAA and some areas of the countries having 1.2 restrictions, are there any plans to maybe use another band for high-speed data?
Right now there's not, and with some of the 1.2 gig areas, a lot of it has to do with the paperwork that is submitted for the towers going up. We did work with one group outside of New Orleans where they had put their power out on 1.2 at 50 watts ERP. When you're looking at the DD mode, that's a 10 watt module. Your hard line or your feed line going up to the antenna, you're going to have signal loss. So you really need to be careful on how you fill out the paperwork and what you're really seeing as an ERP rating. When we talked to the FAA on that, the engineer was taking down the numbers, and his comment was, even with a 16 dB gain antenna, the insertion into the base of the antenna was probably going to be 1 watt to 2 watt max, and there's no way that would be exceeding the 50 watt ERP that was down on the paperwork. So they went ahead and granted that tower approval, and it was real close to one of the airports.
Is there any speculations on replacements for the IC2820 radios?
Nothing on that coming down.
Does the D-Star transmitter have an adjustable time limit?
No, it does not.
Is there a time frame on the next gateway software update?
No, there's no changes coming on the ICOM G2 software. They keep reminding me I got to look at the camera. Sorry about that. I keep looking at the guy that's asking the questions.
I have a 2-meter repeater. Is ICOM planning any promotions that would help reduce the cost of adding a UHF module to the repeater?
Unfortunately not. Since the D-Star infrastructure was first released in 2003, the exchange rate that we've been hit with between the US dollar and the yen has been pretty bad. We've gone from 125 yen down to 80 yen right now, so we've done everything we can do to keep from raising the prices based on the exchange rate.
Can you have 2 D-Star repeaters located several hundred miles apart using the same call sign but with a different band designator?
No, you cannot. And when we were going through the terminology and I mentioned call sign and IP, one call sign cannot exist in 2 different locations. Meaning you have to have a specific call sign and IP address for each one of your repeaters. But you can't have them in the same stack on the different modules that are connected to the controller. The controller is the key to the call sign routing as well as the call sign communication. So the call sign is mounted in the controller, and that call sign will have an IP address as well as every other of the users that are on those repeaters.
What is the thinking of D-Star on hybrid repeaters?
Define hybrid repeaters. Are we talking about analog and digital together?
I'll assume so.
Okay. We have seen this in a derivative called NXDN. And what we've seen in the commercial two-way is where it was a great idea for migration of having analog as well as digital on the same frequency, on the same repeater. There was a lot of frustration because the digital operators had to wait for the analog guys to get off and had no idea why they couldn't talk. And then the analog guys were frustrated because the digital guys were talking. Looking at how narrow the digital signal is, you're able to occupy 2 of those, but you get into the conflict of who has the RF occupied. And I was informed by John here, from his angle, there are also some frequency coordination issues that could arise from that.
Question, what's an ID51?
An ID51 is the new handheld.
Switch to that.
We're bringing up the screen itself. The ID51 is a dual band version. Would help to turn on the 31. Of the ID31. They use the same battery pack. They're just a little bit difference in height, difference in the screen itself for both frequencies to be displayed. And dual band, dual receive on the 51.
And so we'll give you a last question. Are there any plans for Scouts and D-Star?
Any
Scouting and D-Star.
Scouting on D-Star has actually been a pretty fun thing, not only in the United States but also in Europe and I think Australia. There's been different scout nets that have occurred. I'm trying to remember what reflector did they use it for, Joda? I know it was one that but I can't remember which one it was used. But for JOTA, they definitely used the D-Star for that, and also at the Jamboree that is going to be in July 2013. There's going to be D-Star repeaters as well as analog repeaters right there on the Beech Hill Summit facilities.
And so we'll give you a break, and we're going to take a break here until the top of the hour, and we'll get back to our show here on top of the hour. Thank you, everybody, for watching us.